कटिंग फ्लूइड्स और उसके प्रकार यानी व्हाट आर द टाइप्स ऑफ कटिंग फ्लूइड। पहला इसमें आता है कि दोज विच आर मिक्स्ड विद वाटर, जैसा चाहे soluble oils या soap, and these are the emulsion of oil or water or soap and water. Those which are not mixed with water called cutting fluids. Those which are not mixed with water called cutting fluids, or which can be pure oils or a mixture of two or more oils. Those which are not mixed with water called cutting oils, and which can be pure oils or mixture of two or more oils. First, that is your then soluble oil. Soluble oil, जब water increase the cooling effect, or oil provides the best lubricating properties by mixing various proportion of water with soluble oil or soap. Cutting fluids with a wide range of cooling and lubricating properties can be obtained. The ratio of oil to water depends upon the application of the cutting fluids, and the range from about 1:5 to 1:50, and the usual ratio for the various machining operation can be: during the turning 1:25, milling 1:10, during drilling and rimming 1:25, grinding 1:50. Cutting oils basically these are the fixed oils or mineral oils. Fixed oils consist of animals, fish or vegetable oil. Chiefly used fixed oils are lard oil, spurb or whale oil, olive oil, cotton sheet or lean sheet oil, tarpanite oil distilled from vegetable oil is also used. Fixed oils have a greater oiliness than mineral oils, but are not so stable are as mineral oils, and tends to become a gummy and decompose when heated. Mineral oils come from the crude petroleum oils, for example paraffin. To combine stability of the mineral oils with the good lubricating properties of fixed oils, they are often mixed. Sometimes chlorine or sulfur is added to give the property of wetting the metals with a highly adhesive oil film. The imparts are anti-welding properties which help to prevent the formation to build up edge on the cutting tools. Such cutting tools are known as sulfonated oils, and also to prevent the growth of bacteria and fungi which makes the cutting fluids to become the injurious to human skins are phenol disinfectant added. During the machining जो heat resistance और stainless steel है वो pneumonic oil etc, जो pressure or temperature at the cutting edge can be very heavy. Normal cutting oil may not be able to support the heavy pressure at the cutting edge, resulting in welding of metal chip of the tool face. To prevent this, extreme pressure additives the added to the cutting oils, and the most commonly used EP yani extreme pressure additive is sulfur, and the next is chlorine. These additives form the solid films of iron chloride and iron sulfide between the tool face and the chip. These films are easily sheared and have a high melting points. Thus, they help in preventing the chip from welding to the nose of the tool where the pressure is maximum. Chlorine will form a film between the surface at the points of a high pressure, preventing their contact, but at the same time allowing them to slide over the another. तो यहाँ पे हम लोग देखेंगे अब डिपेंडिंग ऑन द वर्किंग कंडीशन, जो बेसिकली 4 टाइप्स के कटिंग ऑयल्स हम लोग कैन बी हैड। पहला स्ट्रेट मिनरल ऑयल्स जो कि सुटेबल होता है फॉर लाइट ड्यूटी एंड हाई स्पीड वर्क के लिए। मिक्सचर ऑफ मिनरल्स ऑयल्स और फिक्स ऑयल्स जो कि सुटेबल होता है फॉर लाइट एंड मीडियम ड्यूटी के लिए। मिनरल्स ऑयल्स with EP additives suitable for heavy duty, mixtures of mineral oils and fixed oils with EP additives suitable for heaviest duty. Then what are the applications of metal cutting? There are some applications. पहला ये application है कि जो cutting fluids होते हैं may be applied for the cutting tools in the following ways: by hand using a brush, by means of drip tank attached to the machine body, by means of a pump for the effective use of cutting fluid for the heavy and continuous cutting. The fluid should prevent into the cutting zone. Particular for this बात करेंगे तो third method जो कि using a pump for supplying a cutting fluid is the most common और this is known as a fluid application. और यहाँ पे जो कंटिन्यूस स्ट्रीम होती है कटिंग फ्लूइड की वो डायरेक्टेड होती है कटिंग जोन में विद द हेल्प ऑफ नोजल या जेट के थ्रू. इसमें दिस इज द आल्सो नोन एज अ हाई जेट मेथड. इसमें हम लोग यूज करते हैं कटिंग फ्लूइड ड्रॉप्स इनटू अ टैंक एट अ बॉटम और बिफोर इट इज recirculated by the pump and it passes through the many filters to remove the chips and dirt. To avoid excessive splashing and vaporizing of the fluid, it is supplied to the cutting zone from the top also. There are some figure that is shows 7.4 figure that is fluid application for the cutting fluid, and there were tool, workpiece, cooling jet and used for two nozzles, and there were job, top nozzles, and there were bottom nozzle in the figure, and there were tool position. So however, the operatives of applying the cutting fluid is expensive and also the high pressure just may be the some danger to operator. Thus, it may be economical procedure for coolant application. It is not universally adopted. Therefore, there are mixed methods of coolant application. इसमें application जो cutting fluid का है is a fine atomized mist है, that is combination of the carrier air और very fine drop of fluid जो कि receive करते हैं considerable attention in the last 25 years. Size of the fluid drops is of the order 10 to 25 micro-m or the mist is sprayed onto the cutting zone at a high velocity of about 300 mph or more and under pressure of the order of 0.28 to 0.42 Newton mm square. जो beneficial cooling effects होता है mist cooling result का from the following facts. पहला due to the high velocity of fluid application the dispersal of heat by convection current is intensified or maintain करना desirable high temperature gradient near the tool surface. Second, the surface area है of the coolant is much greater in the form of mist than the flood application fluid applications, and this increase the cooling capacity of the coolant, and due to the expansion on the mist this issuing nozzles its temperature falls down the considerably. Mist cooling basically हम लोग can be applied कर सकते हैं almost all cutting operation में, but is generally more useful होता है with high hardness work material. It has been proved by the research worker by mist cooling जो less effective है than fluid cooling at significantly higher or lower temperature जो कि 480 डिग्री सेल्सियस से 150 डिग्री सेल्सियस. जब low temperature जो cooling is a heat air conduction into the coolant and in case the stream of coolant is more effective than the mist. जब पर्टिकुलर हम बात करते हैं हाई टेम्परेचर मिस्ट की तो मिस्ट प्रोड्यूस होता है सस्टेनेबल ब्लैंकेट ऑफ वेपर्स अराउंड द कटिंग जोन और ये इट इज हीट ट्रांसफर कोएफिशिएंट बिकम्स पुअर एंड कूलिंग इफेक्ट efficiency decrease. Thus, mist cooling is a more effective than the flood cooling within the limited temperature range, where the flood cooling is loses effectiveness due to the formation of vapor layer under it. So this is the diagram for production of mist. So in the process of producing mist of the cutting fluid is based on the Venturi principle. In this diagram shows that our pressurized air comes on off valve, nozzle and mist. There are inside cutting fluids and there are siphon. This is the production of mist. Pressurized air on off valve, nozzle, mist, cutting fluids and siphon. So the process of producing mist of the cutting fluid is based on the Venturi principle. The high pressure air flowing by a siphon tube draws the fluid into the nozzle and the shape and the density of the mist is then controlled by the nozzle. And the basic components of a mist producing systems are air pump with the air storage, cutting fluids container, piping and spray nozzles.